Hello, from me also. Today I will talk about the application of reclaimed water and sludge in agriculture and opportunities for the Republic of Serbia. Yesterday, Georgia made a well introduction into the circular economy concept and where wastewater can be used or considered as a resource. Firstly, irrigation with nutrient-rich wastewater and utilization of sludge, especially on arable land, is one of the first practices when using those valuable resources from wastewater. Also, in recent times, it is a production of biogas and the recovery of energy from the sludge. So these are some basic facts concerning the value and an amount of wastewater. So yearly there is a growing, increasing wastewater production. Nearly about 400 billion cubic meter municipal wastewater is generated in the world, and the forecast for that wastewater production are that it will be increased for 24% by 2030 and 51% by 2050. Also, over 80% of all wastewater produced is released in the environment without adequate treatment. And also, we know that wastewater is perceived as a growing problem, but also it has perceived as a valuable and sustainable source of water, nutrients, and energy. And we have to change that paradigm shift from wastewater treatment plant to wastewater resource recovery facilities. So on this slide, I presented the real conditions in Republic of Serbia concerning infrastructure of sewage, amount of water that is treated, collected, etc. And all data, there's no accurate database in Serbia concerning all these facts. More data are gathered now in that recent study published in February this year, and that study is a deeper analysis of condition in the sector of wastewater management and guidance for further development. So based on these results of study, we can say that about 4 million inhabitants are connected to public systems for the collection, removal, and purification of wastewater. Also, that means that 63% of population territory of Serbia is covered by public sewage systems. About 300 million cubic meter of wastewater is collected. Among that, about 200 is from households, and another origin is from industries and commercial consumers. Also, about 70 million cubic meter is treated. Among that, only 16 million cubic meter is treated by primary treatment. Number of wastewater treatment plants in Serbia is around 40. Among that, 20 plants are more than 25 years old. 5 plants are over 45 years old, and also today is planned with the help of or under Chinese government program that is called Clean Serbia, to build or to construct about 360 wastewater treatment plants in Serbia in the next following period. So this is a scheme of a conventional wastewater treatment plant, and we can say it's not a one-step process. It is consisting from preliminary treatment, primary treatment, secondary, and etc. That is a line of water, which at the end we obtain treated water or so-called effluent. Also, we have a sludge line where we collect the primary and secondary sludge from the settlers, and that sludge is called raw sludge, and it goes to anaerobic digestion. After the treatment of conditioning and dewatering, it goes further mostly on landfill disposed, but it can be now used as also in agriculture. So after each treatment in the water line, we got there is every different kind of treated effluent that can be or cannot be used in different purposes. So after primary treatment, treated water cannot be used, but after secondary treatment and tertiary treatment, that we get the different treated water with different quality, which can be used, for example, for irrigation of the gardens, swamps, replenishment of groundwater, processed water. Also, after tertiary treatment, this treated effluent could be used for land irrigation, watering crops, car wash, etc. After specific advanced treatment, the treated water could be also used as potable drinking water or for the replenishment of surface and groundwater bodies. As I said, raw sludge represents a valuable resource. After digestion, it can be used as in agriculture for soil amendment or fertilizer. It can be used for biogas production. It can be incinerated, and after incineration, it could that ash represents the reserves of phosphorus, and it can be used also as fertilizer like that. Reused treated sewage and wastewater have many impacts on, especially on environment, on health and economic impacts. Concerning environmental impacts, they refer to soil impact, adverse impacts on plants, and impact of water resources. Health impacts refer to exposure to heavy metals and pathogen concentration, while economic impact are definitely referred or implied to improved crop production and income from those valuable resources. So, concerning environmental impacts, there are definitely nutrient supply reserves because the soil is significantly impacted by using wastewater or sewage sludge, since it provides macro and micronutrients in the form of nitrogen, phosphorus, potassium, and other microelements. Sodium adsorption ratio is also very important because that ratio, if the soil is irrigated with the sewage water, it may be influenced by the content of the wastewater, the type of the soil, and the frequency of irrigation. Also, soil with a high soil absorption ratio may negatively impact to the soil and to the plants, causing plant toxicity, calcium deficiency, and etc. Concerning organic carbon concentration, it affects the soil stability and nutrient retention capacity. Also, organic matter of sewage sludge has the soil nutrient storage, soil biota diversity, as well as reduces exposure to erosion. Slow release of mineral elements from sewage sludge to soil also changes the physical, chemical, and biological parameters of soil and benefits from increased gas exchange, better water infiltration, and retention. Also, dead compounds in sewage sludge are available for a longer period of time. Also, we have microbial activities. They result in better soil fertility. Also, when sewage sludge is applied to soil, it causes changes in the structure and functioning of the agro-ecosystem. Adverse impacts are mostly referred to excessive nutrient availability, and they may result in the toxicity of plants to higher levels of organic compounds and trace element supply. Concerning health impacts, those are definitely heavy metals and pathogens concentration, especially which are excessive concentration. Those heavy metals concentration could contaminate food crops and can cause different nervous, circulatory, and enzymatic disorders, and at high level can cause cancer. Also, they could their mobility and availability depend on plant type, soil characteristics, temperature, pH, humidity, etc. Some pathogens that are followed are disease-causing bacteria, protozoans, and viruses. Among them are Escherichia coli, Salmonella, interstitial nematodes, etc. And according to newly adopted EU regulation for minimal requirements of water use in agriculture, the treated wastewater should be disinfected before application for the irrigation of crops. And at the end, we have economic impact that is definitely improved crop production because wastewater use could help farmers to have a continuous supply for irrigation, but also it helps to provide proper nutrients and crop yields regardless of the season. Also, the quantity of the sewage sludge constantly increasing, and sewage sludge is definitely nitrogen, phosphorus, potassium organic fertilizer containing a full set of microelements necessary for the growth of crops. Also, there could be an income concerning use of those sewage sludge as fertilizer. Farmers can make huge savings on fertilizer because micronutrients and micronutrients supplied to crops are freely available from treated sludge. Also, wastewater treatment plants benefit financially from the scheme as energy consumption has been reduced for wastewater treatment, and having numerous benefits. Adopting wastewater reuse incurs some extra cost initially to both farmers and wastewater facilities operators, and also said yesterday, the excessive amount of money has to be invested in the transportation, storage, and polishing of the effluent to meet the requirements for the use, and for the operators and farmers, they need proper financial support for that. In this table are represented guidelines referred to the use of reclaimed water and sewage sludge in agriculture. On the left side are the all the sewage sludge directive and the fertilizing production regulation that are currently in use. Concerning that field, concerning the reclaimed water, there is a newly adopted European regulation on minimum requirements for water reuse. Concerning Serbia regulation, these are there's no specific regulation directive or something like that. There's only specific documents that are dealing with that are regulating and emission limit values of pollutants in surface and groundwater and sediments. And also last year, there's a regulation, newly adopted regulation on the manner and procedure of sludge management from municipal wastewater treatment plants, because sewage sludge is now regarding as a valuable resource, not a waste. In this table, these are the specifics concerning types of reclaimed wastewater and its quality class. There's 4 classes of reclaimed water that differs among these specific characteristics, and these reclaimed wastewaters are mostly obtained after secondary treatment and disinfection. The characteristics that should be followed are Escherichia coli content, BOD, total suspended solids, turbidity, and some other pathogens such as Legionella and intestinal nematodes. As I said, in the Republic of Serbia, there is no regulation that specifies the use of treated wastewater for irrigation purposes. There are some documents that more closely determine the possibilities of using certain waters for irrigation. Those are regulations, permitted amounts of hazardous and harmful substances in soil, and irrigation water methods of their testing. This regulation contain the maximum permitted amounts of dangerous and harmful substances in soil and irrigation water that can damage or change the productive capacity of agricultural land and the quality of irrigation water, which comes from many industries, improper use of mineral fertilizers, and etc. Also, we have mentioned those regulations on emission limit values of pollutants in surface and groundwaters, as well as sediments. Those regulation describes the limit emission values of purified municipal wastewater into surface water used for bathing and recreation, water supply and irrigation, and they refer exclusively to microbiological parameters. Also, in one slide, I will sum up just yesterday some information just to say that Serbia belongs to the water poorer areas, because the amount of water is about 1,500 cubic meters per inhabitant per year is not sufficient. The lower limit is 2.5 thousand cubic meters per inhabitant. And concerning water exploitation index, which represents the ratio of the total annual amount of water resources used and renewable water resources, Serbia's exploitation index is below 5. That means that Serbia is in a safe zone. Also, it is it's very difficult to give an accurate prediction at this moment, considering that most wastewater treatment facilities are under construction, and to give accurate prediction of water resources in Serbia. But we can give a tentative prediction based on theoretical data, and the project capacities are definitely about more than 7 million equivalent per capita are done, and that indicates that 1.3 million cubic meters of purified wastewater per day will be available from those wastewater treatment facilities as a potential resource. Concerning opportunities for sewage sludge use in agriculture in the Republic of Serbia, sewage sludge is used as according to the law waste management, as a sludge, defined as a waste sludge created in municipal and industrial wastewater treatment, and it has own index number in the waste catalog. In this table, we compared the characteristics of different limit values of pollutants in sludge from wastewater treatment plants meant to use in agriculture. So concerning water sludge, sewage sludge directive, we can say this that our regulation are more strict here than sewage sludge directive, and also some organic substances and pathogens are also tracked in Republic of Serbia based on those regulations, while in sewage sludge directive they didn't track those organic substances and pathogens. And according to the sludge management program in the Republic of Serbia for the period of 2023 and 2032, wastewater treatment technologies and methods of sludge treatment are expected, according to the expected capacity of the wastewater treatment itself, are given, and they are divided to, according to capacity, into three categories. First category are small plants with a capacity of 2,000 to 10,000 equivalent per capita. Second category is medium-sized plants from 10,000 to 100,000 equivalent per capita, and category 3 are plants with a capacity above 100,000 equivalent per capita. That is common for all that category is that sludge mostly will be treated using anaerobic process. So this newly adopted regulation on the manner and procedure of sludge management, which is adopted last year, will be in accordance with the principles of circular economy, and it will be regulated with, as well as with EU regulation. The goal of this regulation will be to ensure the use of sludge as a resource, considering that amount of sludge is expected to increase throughout the territory of Serbia. Also, it contains formulation of short-term and long-term options that will contribute to solve this sludge generated in the wastewater treatment processes. So short-term options are definitely using sludge for agricultural purposes if it is previously composted, digested, or stabilized, used in cement industry, in thermal power plants, as well as disposal of sludge in industrial landfills. Also, it will be used based on short-term options or on landfill disposal of sludge with the provision of special sanitary cassettes intended for those type of waste. Long-term options are definitely based on long-term sustainable systems and infrastructure for that treatment, using best available technologies and good practices. Also, this document advises a long-term concept of regional sludge management from wastewater treatment plant, and it includes the construction of regional centers for sludge management, that sludge could use for recultivation, devastated location, as well as thermal treatment of sludge, drying of sludge, etc. Maximum expected amounts of sludge are more than 100,000 tons of dry sludge per year, and taking into the concern heterogeneity of land in Serbia and determination of need of plant crops for nitrogen and phosphorus, the potential for using the sludge for these purposes can be assessed. Also, the concern arises about the possibility of presence of potentially toxic organic and inorganic components, but this views or this risk should be viewed rationally in relation to characteristic of wastewater, as well as the efficiency type of applied technologies in waterline, which closely are related to quality of the separated sludge. By controlling the users of the sewage system and optimizing the operation of wastewater treatment plant, these risks can be reduced to a minimum. And instead of a conclusion, I would finished my presentation with a future recommendation that with previously mentioned story about recommending sewage sludge and reclaimed wastewater in agriculture, we also need to inform the public about the advantages of utilizing treated wastewater resources. We also have to address the concern of regional communities and include them in the decision-making process, and to assist in developing confidence and support for wastewater resource reuse initiatives. Public gatherings and educational initiatives such as this one today should and can be used to accomplish this. Thank you for your attention.